Welcome everybody, my name is Parker. I'm a mechanical engineer here at McCormick, Stevenson, and today we're going to talk about something drastically important to part model design, especially in respect to creation and the life of the part from design to manufacture. You know what it is, it's design intent. Let's get started. Design intent is a modeling methodology that introduces logical guidelines on how to create a part so that anticipated changes don't change the expectation of what the design will be. These guidelines are almost always contingent on three factors: intended manufacturing method, assembly criteria, and how those relate to editability. Now look, it's not rocket science. Well, I guess it depends on what you're modeling. But it's not hard to take 5 or 10 minutes at the beginning of your project and say, how will this part be made? How will it mate to my other parts of my assembly? How will it connect? And what's most likely to change? And how can I make those things easy to change? Let me show you what I mean. The way the 3D printer works is it prints one layer at a time, from the bottom all the way to the top. And so if I was modeling this, I would model from bottom to the top, starting at the lowest most features and working my way up. If I had something like this pencil holder that's machined, they start with a big piece and they cut away at it until they have the exact shape that they wanted. So if I was modeling it, I would start with a big piece, maybe even find a readily available stock material online, and start cutting that away until you have exactly what you want. And in something more cylindrical, like this McCormick Stevenson cup, any changes that will be made most likely will be in the radial direction. So if I use a revolve feature, then all I have to do is edit the sketch and those changes will be made 360 degrees around. To explain assembly criteria as it relates to design intent, let's look at an example. Your manager asks you to create a tray for the assemblers on the assembly floor. This tray will be a 3D printed part and will have 2 store-bought handles attached to the side. Right off the bat, we know we need to have a flat spot on the outer surface big enough to accommodate the handle's mating surface. We also need enough clearance to tighten the fasteners on the inside of the tray. But your manager tells you before you start that he doesn't know if he wants the tray to be 10 inches across or 6 inches across. For example purposes, I've modeled the mounting holes 2 different ways. One has the holes dimensioned to each other, and that dimension is used to lock the hole pattern to the center of the tray. And the other holes are dimensioned to the edges of the part. Both are valid and both work and are great for this size tray, but one dimensioning scheme preserves good design intent and the other one does not. When we change the size of the tray from 10 inches to 6 inches, the hole dimensions from the edges are now overlapping, and the ones dimensioned to the center have preserved the mates to the handle. Now this is a really simple scenario, but actively thinking ahead of time about the assembly and how your parts will be connected to the other parts in the assembly will help you make sure that the design intent is preserved even when edits are made. Any product you design, you should expect changes, but don't let those changes mess with your design intent. This will make sure that you, your manager, and your clients are happy and will stay happy when 1.5 years later they open up that model to make some updates. You guys know what time it is? It's time for the pro tip of the day. Today's tip is to rename your features on your feature tree to describe what the features are actually doing. This will make sure that if a coworker or a customer gets into that model, they immediately be able to see your design intent and also be able to preserve that intent when they make changes. This also means if you get into the model, maybe months or even years later, you know exactly what you're thinking. And if you're anything like me, you'll say, what was I thinking? Well, that's all we have for this video, but if you want to see more videos like this, please like and subscribe. It helps us out, also helps you out because you get all these free resources to help you out in your job, profession, or whatever you like to do. If you have any questions, please let us know down in the comments. Also, if you have any ideas for topics you want us to cover in a video, let us know. We want to do what you want. If you're interested in McCormick Stevenson and the great work that we do, follow the link down in the description.